All right, so we'll start out this week by finishing up last section in chapter 3, which is on transformations. We focused last week pretty much on lines, shifting a line up and down, left and right. Now we're going to focus on these kind of functions. Okay, so remember, absolute value, if you don't remember what it looks like, it's like a V shape. So everything we draw today is going to be like a V shape. Right? And we'll show you guys how to do it. So I think you guys could probably already answer that question, hopefully. If you look at, let me make it a little bigger in case you can't see it. If you look at the A, the H, and the K, each one of those letters would do something different. Does anyone remember, like when you add or subtract on the end, what does that do? Which way does that shift your graph? When you add or subtract at the end?
Left.
Nope. Inside is when it shifts left or right. Outside would shift what? Up, yeah, up or down. So K is going to move things up or down, just like it did in warm-up problem number 2. All right? Adding or subtracting inside. Right? That's going to be just like warm-up problem numbers 2 and 3. All right? So what these letters do here is exactly the same as what you learned last week. It's just it's not a line, it's a V shape.
And guys, you can see on your you can see like a bunch of boxes and stuff like that. That's gonna be that A square root of in the absolute value. It's gonna be pretty much like that. It's gonna be a little bit more descriptive. That's all.
So absolute value function. Basically, it's anything you write down that has the 2 vertical bars in it. Right? So something like this. That's a relatively simple absolute value with one transformation in it. That -2 is going to move it somehow. Anyone think they could tell me which way a -2 inside would move it? Which way, Youssef?
I mean, inside's a little tricky.
You've got the right, like horizontal or vertical. I agree that it's horizontal, but it's not going to go left. It's going to go right. Everything inside is it's like opposite.
Inside opposite.
Yeah.
You guys, we didn't have you write that down. I think you know if it's an absolute value function, it has the absolute value bars. You don't have to write that down.
Okay. So the simplest kind of function, like you have all different categories of functions. You've got lines, you've got absolute values, circles. There's all different shapes. Well, each category has what we call the most basic function, the one that it's just like a starting point, and that's called the parent function.
So guys, you have parentheses on your first dot there, and your first bullet on your notes. You want to write in parent function, and then outside the parentheses you want to write is y equals x in the absolute value.
So if you look at that one, it's just y equals its absolute value of x. There's no adding, there's no subtracting, there's nothing else that makes it complicated. It's the most simple absolute value function you can have. And every other absolute value function, we're going to compare to this one. Right?
Yeah.
So when we say something like shift down 2 units, we mean, well, if you started with the most basic one you could have, it's that one shifted down 2 units.
And guys, you may not see the y equals. You might just say, it'll say how does whatever function you're given compare to, and then you'll see that x inside the absolute value. You might not see the y equals, but it means the same exact thing.
So we're going to show you guys what an absolute value function looks like. I kind of already described it. It's a V shape. Right? Well, there's one important point on that V shape. Actually, I think I got the picture right here.
Yeah.
And it's the point where the V shape changes direction. It's like the point. Right? And that point is called the vertex. So an absolute value function has a point called a vertex, and that's where it changes direction.
And as you'll see as we go through these, the vertex, right, the x value for the vertex is going to be the first thing that we find when we have to graph.
Because what's nice about these is they're symmetrical. So once you have half your picture, the other half is the same thing. It's just a mirror image because we're going to graph it like Mr. Roy just said. All right, domain and range. Does anybody remember what letter domain is associated with? Is domain your X or your Y? X. So that's your X. And what about range? That's your Y. So if we look at that graph, okay, let's start with the domain. If I were to keep zooming out, does it look like this graph would keep heading to the left forever? What do you think? Nicole? Like it's pretty much, it's just going to be a V shape. Like it's not all of a sudden off the screen going to like turn and do something weird. If it just stays as a V shape, would it keep heading to the left forever? Yeah? And Ellie, how about if it stays as a V shape, would one part of that V keep heading to the right forever?
Yeah.
Yeah. So this graph goes left forever. I mean, it's also going up. And it goes right forever. It never stops. So does anyone remember how we described that? If it goes on forever in each direction, I think it was 3 words we said. Blank, blank numbers. Anyone remember? All blank numbers. All real numbers, exactly. Yep.
Dave, correct me if I'm wrong, isn't that, when you're describing the domain and the range, isn't that always going to be your domain?
Yes.
Yeah.
For all absolute value functions, that is always the domain. Think about it. If you've got something that goes left and right forever, and you shift it to the left a little bit, still goes left and right forever. Right? It doesn't matter. That's always your domain for every single absolute value problem.
So those guys, for the problems we do this week, when we ask you to describe the domain and range, your domain is always going to be all real numbers. Always.
Now, range is a little different. Range is how far the graph goes up and down. Does it look like this graph goes up forever and down forever? What do you think, Gigi? No. Which one doesn't it do? It doesn't go which way? Doesn't go down, right? This graph has a, we'll call this right here, this vertex is like the lowest point, and then it goes up from there. So looking at it, I know it's a little small, but can anybody tell me what they think the lowest point is on that graph vertically? Like how?
What number on the y-axis?
0. Doesn't go any lower than 0. All right? So for this particular graph, the range is all values greater than or equal to 0. Another way to kind of think about it is if I put a horizontal line just like that, and I start dragging it up. Is it hitting the graph right here? No, it's not hitting it. It's not hitting it. I'm waiting till it hits it. I'm looking for the first time it hits it. Right there. So the first time it hits it is at 0. And then is it still hitting it? Still hitting it, still hitting it, still hitting it. It's just going to keep hitting it forever as it goes up. So that's why it goes every value greater than or equal to 0.
Guys, your range is always going to be the lowest, not the lowest point. Or if there's for some reason a reflection or something like that, most of the time it's going to be the lowest point that the graph touches on the y-axis. In this case, it was 0.
Right, so we've got basically 8 different transformations, just like you did before. We've got some stretches, we've got some shifts, and we've got reflections. So let's just kind of go through and see if we can write down what each one of these do. It's kind of almost like the chart you did 2 days ago. In fact, you really could almost use the same kind of thing. So the first one is what operation? If you look at what you have right there, what operation is that? All right. So what operation do you guys see there besides the absolute value? Addition. Where is it? Inside or outside? It's outside. Addition outside. What does that do to my graph? Think back to the warm-up. Addition on the outside. Vertical shift. Give me a little more specific.
Up.
Up. Exactly.
You guys don't have to worry about writing this yet.
So the graph is shifted up a certain number of units. Okay? So shift up a certain number of units. All right? How about this one? X minus a number. Yep, that's a vertical shift down a certain number of units. It would be whatever the number is. If it was 2, it would be shift down 2 units. So when you're writing these, there's no factor. Like you don't say shift down a factor. No, a factor is when you multiply. All right? So if I was going to stretch something, then I would say stretch by a factor of whatever. But this, you just say shift, and then the direction, and then the unit. Okay. How about this one?
Mr. Hager, could you say for that, could you say a vertical shift? Would that be okay, or?
As long as you say up or down.
Okay.
Yep.
If you just said shift up or down, that's fine too, right?
Yeah, if you say
you
shift
don't
up,
have to, so you don't have to say vertical.
what you do have to say is up or down and a number. So I've got to see up, down, and then a number. Not up and down, one or the other, not both. How about this one? It's addition inside. So we know addition outside was a shift up. How about addition inside? Which way is that going to shift it? Yep. Horizontal shift which way? Well, we just said this one was down. So this one is a little different. So down is when you subtract outside. This is adding inside. Yep. It's going to shift left. Exactly.
Inside, opposite.
So that would be shift, you could say left 5 units. Shift left 2 units. You don't have to say horizontal because when you say left, I know left is horizontal. All right. How about this one? X minus a number. Okay, well, I just gave it to you. Shift right. Okay, so X minus a number, that's when you shift to the right. Any questions on that? So those are your 4 directions you can shift. So you want to look, did you add or subtract? That'll tell you part of what you need to know. And then, did you do it outside or did you do it inside? So knowing those 2 things basically tells you which way it's going to shift. All right. Any questions on that? All right. So when we describe transformations, right? Like if you have a problem like something like, well, yeah, like that. There's a few different things happening there. Right? The 2 is going to do something, the negative is going to do something, the -1 and the +3. We can't just name them randomly and say, oh, it does this, it does that, it does this. We got to put them in a certain order. So that's what this is. Okay. Does anybody remember from last week, and it's the same order that we've already done, what would be the first thing that you always list? Anyone remember the first one that comes up?
Horizontal shift.
Yep, horizontal shift. But positive would be,
Should be left.
okay. So positive would be to the left.
Yes.
I always have to think about it because it's always backwards. So when you see me pointing, I'm thinking in my head. And then negative would go to the right.
Inside, opposite.
So you got your horizontal shift. In fact, all of this stuff is going to be horizontal. Always deal with all the horizontal stuff first. Okay, what about the next one? After horizontal shift.
Horizontal stretch.
Yep, your horizontal stretch.
You guys, once Mr. Hager scroll down to the last horizontal, then you'd be able to draw your arrows to where it would be in the problem.
So remember, horizontal stretch, that one's a little different when you write it. And Joe gave us the example perfect in the warm-up. horizontal stretch by a factor of 1 over number. I think that's in the notes though. And there's one more horizontal thing that can happen. You've got your shift, you've got your stretch. What's the last thing? Yep, Maddie? Think you know? Not sure? Reflection. Horizontal reflection. So that's when you see a negative. All right? So what we've done here is we kind of took this and just put boxes to leave it blank, and we pointed to what each box would do. Don't worry about the first box and the last box yet. We haven't done those. Just write down for the 2 boxes inside. Right?
Remember guys, if you have a negative on the inside, like that horizontal reflection that it's pointing to, all you'd have to write is flipped over the y-axis. That's all you'd have to write. There'd be no, you say, am I right? There'd be no by a factor of whatever. We just
No.
say it'd be flipped.
Yep. The only time you say by a factor of is when you do a stretch. That's the only time you say by a factor of. Don't say it for anything else. Okay, so the box on the right that's inside the bars, that's your shift. The box in front of the X, that would be your stretch. And remember, if that number is a negative, that will also cause a reflection.
So if it was negative on the inside with the X, all you'd have to write for your description, where your comparison is flipped over the y-axis. That's all you have to write.
Okay, so 1, 2, and 3, that was all your horizontal. What do you think 4, 5, and 6 are? Yep.
Vertical.
That's all your vertical. All right. Does anybody remember the first vertical one we do? And it's actually not the same order. It's not shift, stretch, reflect. Yep. Stretch. So the first one is a vertical stretch, and that's what that first box, that's part of what it can do. It can stretch. And what else do you think it could do if that number was a negative? Just like the box in front of X. What did that do if that was a negative? Yep.
Vertical shift.
Not a vertical shift. Remember, shifting has to do with adding or subtracting. But when you throw a negative in front of something, that causes, Gigi, a reflection. This is a vertical reflection. So up to down. It's like up to down. So that would be a flip over the x-axis.
You don't have to say anything about a vertical reflection. And all you'd have to write if you had that, it says flipped over the y-axis. Nothing more than, you just have to write those 4 things. Flipped over x-axis.
And what's the last vertical transformation I have that we haven't said yet?
Vertical shift.
Vertical shift. So your positive is up.
And there's nothing opposite. If it's on the outside, there's nothing opposite about that.
And negative is down.
Positive up, negative down.
All right, so let me just take a look at.
Okay, your comparison, guys, if we're talking about a stretch, you'd write it like that.
Yeah, so when you're talking about a stretch, sometimes it's by a factor of, sometimes it's by 1 over.
Yeah.
We're gonna talk more about that.
Yeah. And guys, you're gonna have examples of everything too, of how to write them. So as long as you can look back at your examples and know what it is, you should be fine.
Yeah, don't worry about that.
Yeah. So you want me to do this part? All right, so guys, when we do these type of problems, we're gonna have to do 3 things. All right, we're gonna have to graph it. We're gonna have to describe what it does, shift, reflection, whatever, and then, like Mr. Hager showed you at the beginning, the domain and the range. So those 3 things always when doing these type of problems. All right. So first thing, now we're talking about graphing it. We're gonna have to make like a little table, a little XY table. All right. So first thing we want to do is set what is inside the absolute value bars equal to 0 and solve. When we get that number, right, use this number as the middle x value in your table. That value we found is going to be the x value for our vertex. Like we talked about, when the graph starts to change directions, that's the x value that's going to happen. On the x-axis, that's what's going to happen. So when we set what's inside the absolute value bars equal to 0, we're going to ignore the absolute value bars. All right? Kind of like, remember before we did like the, we had to like split them. When we were solving like equations, we had to split them, set one equal to positive, one equal to negative. But when we solved, we kind of ignored the absolute value bars. We're doing the same thing here. And guys, for each step in this, each step for graphing, you're going to have an actual example. So you'll see what it looks like, what happens step by step. Because we're going to work through, we won't do everyone like this, but for this one right here, we'll go step by step so you can see what happens, right below each step. All right, so like I said, you're going to get the x value for your vertex by doing this. But remember, when we solve what's inside the absolute value bars, we're going to ignore the absolute value bars. You're not going to write them, right? You're not going to need them. All right? So I know some people are still writing now. Leave it up there for a few more seconds. People can get that written down. Again, and once you get this first number, everything else is going to kind of fall into place. It's like once we go through this, you'll see there's like a little pattern that we can follow. All right. So I know some people are still writing down, which is fine. This is what your first example is going to look like. All right. So we have m of x equals the absolute value of x minus 2. That's what it's going to look like. So like I said, for this example, we're going to go through step by step. So you guys have this written there. You just have to fill in what the absolute value is. So like I said, we said for our first step, we want to take what's inside the absolute value bar and equal it to 0. So how am I going to do that? What am I going to write? Take what's inside the absolute value bar and make it equal to 0. So what's that problem going to be? What's inside the absolute value? X minus 2. Take what's inside x minus 2 and do what? Take what's inside, which I just wrote, and then do what? Make it equal to what? Make it equal to 0. I'm just doing exactly what the step says. Take what's inside, I pulled it out, made it equal to 0. One step, and I'll have solved for this part. I'm going to solve for my x value for my vertex. How would I solve that? What do I have to do? Matt?
Add 2.
Add 2. Just add 2. Plus 2 plus 2. X equals 2. All right? Now I'm not done yet. That just gives me my first value. Now I can start with my chart. All right? So, for step 2, we need additional values, x values, for our table. Pick the 2 x values that are smaller, all right, that are smaller than this number, and the 2 x values that are bigger than the number from step 1. What I like to do is, guys, when I do this, and it'll make sense when we go through it, I like to pick the 2 higher numbers first, because then I'm dealing with positives. Even though we're doing absolute value, we're never going to really deal with negatives. Because like we talked about, absolute value measures the distance from 0. Even like we talked about before, if I'm walking backwards, doesn't mean I'm walking a negative distance. If I was wearing a Fitbit or something like that, I would still be adding steps. I wouldn't be losing steps. All right? So like I said, we have the x value for our vertex where it's going to bend. There's no other math required to get the other x values. You just need to know what 2 numbers come after 2. Yeah, what comes after 2, what comes before 2. The 2 numbers that come. If I'm counting up, what 2 numbers come next? If I'm counting down, what 2 numbers come after that. That's all we're going to do. All right? So again, The only math we've done so far for this is just setting what's inside the absolute value bars equal to 0, solved it, got us our x value. So I go down here. My middle value is x. So I want to put that right in the middle of my chart. Now the directions say I want to pick the two numbers that are greater than 2, the next two numbers that are greater than 2, and the next two numbers that are less than 2. So what are the next two numbers that are greater than 2 if I'm going in consecutive order? What are the next two numbers if I'm counting up? Ellie?
3 and 4.
3 and 4. What are the two numbers that are consecutive that are less than 2? Ellie?
1 and 0.
1 and 0. There's my x. So I figured it all out. That's step 2. Here's my vertex. That's going to be my vertex. I'm going to figure out, we're going to get to how to figure out the y values in a second. But that's going to be the x value for my vertex. We're going to get to how to figure out the y value in a second. So again, all we're doing is for the x values, setting what's in the absolute value equal to 0. Pick the two numbers that are greater than that number, consecutive, the two numbers in consecutive order that are less than that number. All right? Fill in I got half of my chart filled in. Step 3, calculate the corresponding x values using the absolute value function that is given. So like we talked about in step 1, I said when we're solving for the x value of my vertex, ignore the absolute value. We're not worried. We're going to pull it out. We're going to set it equal to 0. We'll get our x value for the vertex. Now, when I'm solving for my y values, I've got to make sure I don't ignore the absolute value. If it's in the absolute value bars, it needs to be in the absolute value bars. All right? We're not ignoring those now. They need to be there. All right? So calculate the corresponding y values using the absolute value function that is given. All right? So if I scroll back up, there's my absolute value function right there, x minus 2. I'm just going to put that right here, just so we know. X minus 2. All right? What's my first problem, the first thing I set up, my first function? What am I going to write? Because I have my x value, it's just a matter of plugging it in. What am I going to write? Ellie?
-2.
No, I already have the -2. That's part of the function. That doesn't change. I know I have 1, 2, 3, 4, 5 different x values right now. If I'm going in order from greatest to least, what's my first x value that in order of my chart? 4, right? Here's x right here. What am I going to write in for x? What am I going to write in for x? Look in the left-hand column. 4. It's up to you. You can set them all up at once or do it one by one. It doesn't matter. So it'll be 4 minus 2, 3 minus 2, 2 minus 2, 1 minus 2, and 0 minus 2. We can set them all up at once. Now, when you're doing absolute value, you have to understand when I'm solving these, if I get a negative number, it can't be negative. Anything that's inside the absolute value bars, when you solve and the result is negative, it changes to positive. Because remember, absolute value measures the distance from 0. We can never measure distance as negative. All right? And this is the reason why I say do the positive numbers first. It'll make sense. All right? 4 minus 2? 2. What's the absolute value of 2? 2. 3 minus 2. What do you get?
1.
What's the absolute value of 1? 1. 2 minus 2.
0.
Absolute value of 0?
0.
Okay. I'm going to save you a lot of pain and agony and extra work. See this middle value here of 1? this value, this y value down here will be 1 as well. 1 minus 2 is negative 1. If negative 1's in the absolute value, it has to become positive. That's why this is 1. Because this would be this would look like negative 1 like that. It becomes positive 1. Absolute value can never be negative. Same thing here. The outside value, the top value, matches the top y value, matches the bottom y value. It's 2. Right? The two after the vertex always match up, and the top and the bottom always match up. The 2 inside and the 2 outside always match up. The y values are always the same. It's like Mr. Hager said when he was going over earlier in the lesson. It's symmetrical. It's going to be even on both sides. All right? That's how you do your chart. You only have to solve for these first 3, because this will match this, inside will match inside, outside will match outside. Don't do any more than that, because I think with the absolute, so you know it's negative 1, you're going to leave it as negative 1? No. Once you do these first 3, you have the last 2. All right? So we just did that. I did step 3 in this part, so if this is blank, that's okay. All right, now, I have to graph it, right? I'm going to graph it, compare it, and describe the domain and range. I don't think I have a, there we go, okay. So, it's going to be tough, but let me go, I'm going to scroll up. I'm going to graph my vertex first, all right? And give you guys a little more time, you have to write that step down. So graph it, compare to the parent function. Remember, the parent function's this. So it's, you don't have to write this. But when I ask about comparing it, it means how does this compare to the, remember, this right here is the parent function.
So
How does this compare to the parent function?
So
What's up,
like the child is like those the child and that's the parent or something?
Yeah, this is like the king of all absolute value functions. Right? All others must like bow down to this.
Okay.
All right? So graph compared to the parent function, what's going to happen, and then we're going to describe the domain and the range. All right? So to graph it, go back to your chart you filled in with all your values. You say you're going to bring that down? Cool. So Ms. Hager's just going to bring it down, so I have to go back and forth. All right? So I'm going to graph the vertex first. What's the coordinate for my vertex? Someone tell me by raising their hand.
Like
Yusuf? Yeah, what's the coordinate? 2, comma.
Oh,
2, 0, right? Here's my x, here's my y. So I go to 2, I go to 2 on the x-axis. I don't go up or down because it's 0. There's my first coordinate. All right, I'm going to go back to the beginning now. What's my top coordinate on my chart? What's the first one? 4, comma 2. 4 on the x-axis, 2 on the y. What's my next coordinate after that? 3, comma 1, right? 3 on the x-axis, 1 on the y. I already did my vertex. I'm going to go here. My next one is going to be at 1, comma 1. I go 1, I go up 1. And I'm going to go 0, 0, 2. Remember, those lines aren't going to be curved. They're going to go, like Mr. Hager talked about in the beginning, they're going to go straight up. They're going to go straight up. All right? So now we have to go back, and then those notes we just took with the boxes to see what happens in each step, right? Or when we're comparing. Here's my function. I have stuff happening on the inside. So how am I going to write my comparison to the parent function? What's happening from absolute value of x minus 2 compared to the parent function? What's happening? What's What is the graph that we just drew? What's happening to it? Where is it moving? Up, down, left, right? So the parent function's kind of like this. Yeah, if we go back, right, it's right smack dab in the middle. All right? So if I go back, right, what's happening, because the parent function's right, let me say you're running over. There's the parent function. What's happening to this compared to this? Savannah? Shifted right, okay. Shifted right, how many? 2. So how am I going to write my comparison? Yeah, shift right 2 units. It's going to shift right. It's going to shift right 2 units. Remember, it's on the inside. Inside means opposite. Inside always also means horizontal, right? Left to right. There's your description. All right? My domain. I said at the beginning, the answer to your domain is going to be the same every single time. What do I write? Good use of all real numbers. Now, my range. How do I figure out my range? Is that going to be my x values or my y values? My y's, good. When I'm talking about my range, it's the lowest number my graph hits on the y-axis. What's the lowest number my graph hits on the y-axis? Not the x, the y. Ellie?
2.
That's the x-axis. 0. Good, Chris. 0. What letter do I have to write to describe my range? What letter? What is range? The y value. All those numbers in the range are going to be what compared to 0?
Equal to?
Bigger or smaller? They're going to be greater than. But they're going to be greater than or equal to. Because look it. It's filled in, right? The dot's filled in. We got to kind of remember back a couple months ago. If it's filled in, that number's included. So there's my domain, there's my range. All right? Again, range is the lowest your graph goes on the y-axis. The lowest your graph touches on the y-axis. In this case, here's my y-axis. It touches at 0, not at 2. 2 is the x-axis. All right? Let's look at another one. This one. Graph each function, compare each graph to the graph. Okay. So we're doing the same thing. We're going to graph it. We got to describe it. We got to give domain and range. What's the first thing I have to do? What's step 1?
Oh,
Yusuf?
aren't you supposed to like pretend like the x, like the bars are not there?
The bars, take what's inside the bars. Pretend the bars aren't there. So what do I have to write?
X plus 3.
All right, x plus 3. Just what's inside the bars. So I agree with that. Take what's inside the bars. Pull it out. And what else do I have to do? It should be right there in step 1.
Oh, I'm like that.
Savannah? Equal to 0. Now, when it's something like this, I don't have to do any more. It's done. X equals 0. There's no plus, minus, nothing attached. It's done. Now what do I have to do? Now I'm on step 2. What do I have to do now? If you're not sure, look at your front side of your notes. If you're not sure, look at your notes. We're on step 2 now. No, not yet. Before we do that, we're on step 2 on the notes.
Are we on the second graph in the front?
Say again, Joe.
Are we on the second graph?
We are on. Yeah, we're going to be on. We're on the front side. Example 1B. So bottom left-hand corner. You guys have this written. You just have to write this.
Yes, but it's where it says G.
Huh? What says G?
Yeah.
All right, let's change. You can just change that. There you go. Now I get the same as you. All right. So now what am I going to do? So step 2 says we need additional values for our table. So this is when we pick the two above and the two below, right? So I set up my XY table. Where does 0 go? Ellie?
In the middle.
In the middle, right? What are my other numbers going to be?
1 and 2.
1 and 2.
And then -1 and -2.
-1, -2. All right? So again, I have my additional values. Now, I have to get my y values. How do I do that?
Do the same thing that you did on the other side.
So I have my x values, right? How do I get my y's? Guys, so you have the notes right in front of you. Look at the notes. Read them. Ellie?
And two x values that are bigger than the number.
We did that.
So would you like calculate the corresponding y values?
How do I do that?
Using the absolute value function that is given.
Okay, so here's the absolute value function that's given.
3.
Joe, what were you going to say?
Plug in the
Plug in for x, right? So what's my first problem going to look like, Joe?
2 plus 3.
Remember, make sure you put it inside the absolute value. Absolute value of 2 plus 3. If you want, go ahead and set up all of them. My next one's going to be absolute value of 1 plus 3. Absolute value of 0 plus 3. Absolute value of -1 plus 3. Absolute value of -2 plus 3. Now I'm going to solve, and it's going to give me my y values. Can someone tell me the answer to the first one? Absolute value of 2 plus 3, Ellie?
5.
5. Absolute value of 2 is 2. 2 plus 3 is 5.
The next one's 4.
Next one's going to be 4. Absolute value of 1 is 1 plus 3 is 4.
And then 3.
3. Stop. Why do I say stop?
Because there's negative.
Okay. Without even doing any math. Absolute value of -1 plus 3. We already have the answer. What's it going to be? How do you know that, Ellie?
Because it's basically what the absolute value of 1 plus
Remember,
3 is opposite.
these match. These match.
Because
What-
you can't have a positive.
Mhm.
I mean, you can't have
Negative.
a
What's my last y value going to be? 5. They all, remember, once you do the first 3, these last 2 are going to match up. Mr. Hager, did you graph it? So guys, what Mr. Hager did was, he just went ahead and graphed it. You can see, all right, here's my coordinates, 2, 5. So I'm at over 2, up 5. Over 4, over 1, up 4. So all the coordinates, again, these are your coordinates. Go over to 2, go up to 5 on the y-axis. Go over 1, up 4. Start at 0, go up 3. Start at -1 on the left, go up to 4 on the y-axis. Start at -2 on the left, go up to 5. All right? That's how I do that. Now, as far as comparing, all right? Before, let's go up just a little bit, Mr. Hager. Before, I had stuff going on inside the absolute value. Now I have stuff going on outside the absolute value. So what does that make the graph do? What direction, Yusuf?
No idea.
Not sure. And again, guys, if you're not sure, we did that whole thing there where we drew the lines and everything with the boxes and everything like that. If you look,
Oh yeah.
we have something at the end on the outside. What does it make it do, Joe? Move up how many? Huh? So what am I going to write for my comparison? Shift.
Shift up 2.
Not 2. Keep going. 3 what? Yeah. Shift up 3 units. All right. So for that, that's all I'm going to do. It compares. It's going to shift up 3 units. Domain. Very simple, right? It's the same thing every time. What's my answer for domain? All real numbers. Now, my range. How do I figure out my range? Someone tell me by raising their hand. How do I know what the range is? Savannah? Yeah. The lowest that your graph touches, the lowest point your graph touches on the y-axis. So Nathan, what's the lowest point on the y-axis that my graph touches? 3. What letter should I have in my description? Y. What sign should I have in my description? Same exact sign I had in the last one. Example 1A. Example 1A. Greater than or equal to.
Oh, God.
This is the same every time. My range, we're going to put y in there. It's always going to be greater than or equal to whatever number, the lowest number that your graph touches on the y-axis. All right? So now, this one. Same thing. What do I do first? Huh? Good, Chris. Take what's inside the absolute value, pull it out, make it equal to 0. Did that. Next. What do I do next? Do I only need one x value? Ellie?
We need additional x values.
Okay, how do I get them?
Pick the 2 x values that are smaller.
Mhm.
So it would be
Guys, I think on your notes. Yeah, guys, we're just gonna call. Yeah, okay. Example 2A, we're good. So, guys, you're on the bottom. You're on the bottom right on the front side of your notes. Huh? What happened?
Oh.
Okay, you all set, Donovan? Wake up back there, buddy. All right. So x and y, right? Where does 0 go? In the middle. What are my other numbers going to be? How about Paige? What are my other numbers going to be? My other x values.
2 and 1.
2, 1?
Negative 1, negative 2.
-1, -2. If it helps you to count down, that's fine too. Okay? Here we go. Now I got to figure out my y values. What do I have to use? What do I have to use to figure out my y values? The formula, right? So what am I going to, I have my first x value is 2, Donovan. What am I going to write? Here's it. You said use the formula, or the function, there it is. I agree with you. So what's the first thing I'm going to plug in for x?
0.
We can do the vertex first if you want, that's fine.
Okay.
So what am I going to write? I'm going to write 2,
Plus.
no plus, look here.
Oh, multiply.
Yeah, so I'm just gonna put the absolute value bars. Inside the absolute value bars, what am I going to put?
0.
0. But like Donovan said, this does mean multiplication because there's no sign to separate them. So when they're side by side, it means multiplication. Ellie?
So would the first one be 2 absolute value of 0?
Not absolute value of 0. What do you?
Absolute value of 2?
Yeah, we'll plug it in. Plug it in each time.
Oh, I see.
2, absolute value of 1, 2, absolute value of -1, 2, absolute value of -2. You're just taking these values and plugging them into x. That's all you're doing.
I have a question.
Yes, you said.
Does it matter like what order you put it in? Do you like the absolute value bars first and then just 2 regular? Is that okay?
Well, the order matters because of when you have to describe it, what's happening, the order does matter. I don't want you to get confused. All right, but like you guys said, this does mean multiplication. All right, this does mean multiplication. All right? So 2 times the absolute value of 2? 2 times the absolute value of 2 is going to be what?
4.
4. 2 times the absolute value of 1?
2.
2 times the absolute value of 0.
0.
Stop. What's my next y value going to be?
4?
No.
1.
2. What's my last y value going to be? What is it going to be? 4. Remember, you don't have to solve these. This always matches up. That always matches up. All right? So, Mr. Hager already graphed it. There's all our coordinates. All right. Again, it's symmetrical. Means it's an equal amount on both sides. Now, if we go back and look at the beginning of our notes with all the boxes, right? If we have a number outside the absolute value to the left, what is that called? What's happening if I'm comparing it? We have a number on the outside to the left of the absolute value bars. What does it cause? What happens to the graph if you have that?
It moves.
Okay, so again, if it were me, I'm looking at my notes right now. I'm looking at that first box. The first box on the outside, it kind of looks like this. You have a box, then you have the absolute value bars. That box on the outside. What's happening with that box? I mean, see, we have a number here outside the absolute value. What happens, Ellie?
Do you multiply it?
It's multiplying. What does it cost? If I have to describe it or compare it, what is it making the graph do? Like before, we had one that went. We had one that went to the right. We had one that went up, right? Shifted up, shifted right. What's going to happen to this one? Look at Mr. Hager's doing.
He's
Up
going
and
up and
down.
down.
So
And what's happening to the graph?
Oh, he's stretching it.
Good. So, what am I going to write? What am I going to write for my comparison?
vertical stretch?
Vertical stretch. Keep going.
And domain is all real numbers.
No, we're not done. We can't just write vertical stretch. We need more than that.
Something units.
Oh,
By a
vertical stretch up.
by a factor
Of 3.
of
Oh, wait, no, 2.
2.
See this one?
Vertical stretch by a factor of 2. Remember, if it's plus or minus on the inside, plus or minus on the outside, if it's inside, it's going to go left to right. So you can just say shift left 2 units. If it's outside, you can say shift down 3 units. When it's stretching vertically or horizontally, you have to say by a factor of. All right? And like I think Ellie just said it, for your domain, all real numbers. And then for your range, what's the lowest that the graph goes on the y-axis? The lowest that it touches?
0.
0, right? What letter do I have to use? Y greater than or equal to 0. All right? Now this one. Say, don't want to do it? You want to do one, Mr. Hager? Sure. We're in pretty good shape.
So I skipped the other one because this one, it's pretty much the same thing, except instead of a stretch, it would make it compressed a little more. So we're not going to do that one. Let's do. Okay, let's try this one because we haven't done one with a negative. Okay. First step. What do I do with what's inside the bars?
Guys, you're on the top right-hand example on the back side of your notes. Example 2C. We're not doing 2B.
What do I do with what's inside the bars?
Oh.
Ellie?
Set what is inside the absolute value bar is equal to 0.
Yep. And now solve it. But is x already by itself?
Yeah.
Done. You don't have to do anything else there.
Light work.
That's going to be the middle value in my table. What's going to be the 2 values that are smaller?
-2 and 1.
So we've got -2, -1. Yep. And what else? 2 values that are bigger.
1 and 2.
1 and 2.
Oh wow, so you did the opposite.
Yeah, it doesn't matter which way you do it. And now we plug each one of them in. Okay, so to save time, I'm just going to plug them in and we'll do it together. When you plug in -2, what's the absolute value of -2?
2.
2 times -2.
-4.
Yep.
You did 1, 0.
Next one. Plug in -1. What's the absolute value of -1?
1.
1 times -2.
-2.
-2. Let's do 0. Absolute value of 0.
0.
0 times -2.
0.
Stays a 0. And now from here, you're going to see the same pattern. Absolute value of 1, 1 times negative 2. Negative 2. And the last one's going to be negative 4.
2 insides match up, the 2 outsides match up.
So let's graph it. Left 2, down 4. Left 1, down 2. 0, 0. 1, negative 2. Okay, what's looking a little different here?
It's like upside down.
It's upside down. Why did it go upside down?
Because
It's negative.
it's nice.
Right. We had that negative in front.
Like,
So when we compare this one, there's two things happening. The 2 and the negative. Let's start with just the 2. You guys just did that on the last problem. What does a number in front do? Forget about the negative for now. Pretend like it was just a 2. Ellie,
Vertical stretch.
Yeah.
keep
By
going.
factor of negative 2.
By a factor of what number?
Would it be negative 2 or would it
Nope.
still be 2?
0.
2.
Oh.
Yeah, because remember, the 2, like Ms. Hager just said, the 2 and the negative, when you're describing it, they're two separate things. It's going to stretch, the 2 will make it stretch, but that negative also causes something else to happen.
And what's that something else that's going to happen? What does the negative do?
It makes it open the other way, right? Instead of opening up, it opens down, but what do we call that? Good.
Nice.
Reflect.
Joe, on fire.
Reflected where though, Joe?
Reflect. So your choices are over x-axis or over y-axis?
Over the X.
I don't know why I got it.
Think about what we did last week.
It's the Y.
It's flipping.
It's almost like
It's flipping.
That's
Well,
the
Yusuf,
X.
did you say y?
Yeah.
Well, it's flipping. I think I heard the other answer too. It's flipping up to down. So this one, it's not over the y.
It's over the X.
Right on the Y.
Someone else said it. Yeah, this one is over the x.
It's over the X.
I think I heard both, but yeah, it is over the x. Now, what's the domain here?
Would it still be all real numbers?
Still all real numbers. That never changes.
Nice. It's like good for the test.
Now, does this graph have a low point and go up forever? No.
Whoa.
What does it have this time?
Oh my God.
Down? Like
Yeah, it goes down forever. So this graph has a high point and then it goes down. What's the highest that this graph ever goes?
0.
0.
0.
What letter do we always use with range?
Y.
Y. And now the values are they above 0 or are all the values below 0?
Oh, less than or
So
equal
less than
to.
or equal
Exactly.
Yes.
So when you have that, you have to make sure you put it less than or equal to. Let's I'm gonna skip that because we've done it. We're gonna go.
It's that last one probably, right?
Yep. We're gonna skip to the last one.
Thank God.
So example 4. So this one, all I want to do is describe the transformations. Okay, I'm not gonna graph it.
Let's go.
Again, so as you, again, look at you're not sure, flip over to the front side of your notes. You have the list, and you have arrows pointing to each thing and what it's going to cause to do.
Someone tell me what number am I gonna focus on first there? Ellie?
Would it be negative 2? No, it'd be the X minus negative 1.
X minus 1. So start with that minus 1. What does that minus 1 do?
It turns into a positive one.
Huh? Nope.
Yeah, it's inside the absolute value bars.
So we're just looking to describe these things now. We're doing those 6.
Oh.
If it's negative or positive, that just tells you left or right. So you don't have to do any arithmetic. You just have to remember which way is which. So what's that minus 1 gonna do?
No idea.
Shift to the right.
So negative is
Shift
right.
down.
No, inside
Yeah.
inside is always horizontal. Shift right. How many?
1.
1 unit. Shift right, 1 unit. What's the next number we look at?
Can we do another one?
-2.
The negative and the 2. That's two separate things. The negative is doing something, and the 2 is doing something. What's the 2 doing? We've actually seen that in a couple problems today.
It's multiplying.
It's multiplication, so what kind of transformation is that? Stretch, which way?
By a factor of 2.
Exactly. Vertical stretch by factor of 2. Now we've done the -1, we've done the 2. What about the negative next to the 2? What's that going to do?
Guys, you should all be like flipped over looking at the front side of your notes. And see whenever you have a negative attached to the outside, what it makes happen, not just standing there and staring at the board.
Yeah. Vertical shift, I like that, but that's going to be the last. That's when you add or subtract outside. So the last one is your vertical shift. What about that negative? We just did it on the last one. That's a reflection. Reflect vertically. Reflect over x-axis. So those are your four transformations. All right, so we'll take a little bit more of a look at that tomorrow when we go over the homework.